So what we'll be talking about in this short video is the stress-strain behavior of steel. As steel is the reinforcement in reinforced concrete, it's very important that we understand the behavior. So there are several different regions of the stress-strain curve. We start with the elastic region, in which we have a linear relationship between stress and strain. At a certain stress, we will reach the yield strength of the steel. In typical steels, if you're testing it, you're going to get a little bit above the yield, and then it's going to return to the yield. So then we'll move to the yield plateau, which is a region in which we'll increase our strain but not increase our stress. And then at some point we'll hit what we call strain hardening, where we start to pick up stress again when we increase our strain. It'll reach a maximum or ultimate strength, and then it'll start to decline until it ultimately fails. So just to remind us of the different regions, we have our elastic region. We have our yield plateau. And then we have our strain hardening region. So typically we'll idealize this curve in several different ways, which we'll look at in a later video. But I guess some other important points that we'll need are our yield strain, our strain hardening strain, our modulus of elasticity, and occasionally we will also need our ultimate F sub U, our ultimate strength, and ultimate strain. These properties are dependent on the steel, but our typical ranges will be for yield, we'll have our yield strain is equal to our yield stress over the modulus, because we have a linear relationship, and this is typically about 0.002 for grade 60 steel. And for grade 60, our yield strength is 60 KSI. So then for grade 60, our strain hardening strain is about 0.01 to 0.02, and our ultimate strain is about equal to 0.1. So these are the values, and in the next video we'll look at some ways to idealize these curves.